Hey everyone, welcome back to the channel. In today's tutorial, we are diving deep into image recognition using TensorFlow and especially leveraging the power of transfer learning. By the end of this video, you will have a solid understanding of how to apply transfer learning to your own image classification task and harness the power of pre-trained models for better performance and efficiency. So let's get started. So first thing first, image recognition is a crucial aspect of computer vision. It involves teaching a computer to identify and classify objects within image. It has application in healthcare, autonomous driving, security system, and more. Now, TensorFlow is an open source library developed by Google that make it easy to build and train machine learning models, including those used for image recognitions. So TensorFlow provides a rich ecosystem for machine learning, and with TensorFlow 2.x, it has become even more user-friendly. But a powerful But as powerful as TensorFlow is, training a deep neural network from scratch can be time-consuming and resource-intensive task. That's where transfer learning comes in. So what exactly is the transfer learning? So transfer learning is a technique where we have a model that has already been trained on the large data set and fine-tune it for a specific task. Instead of training a model from scratch, which require a lot of data and computational power, we reuse the knowledge from existing models and adapt it to our task. For example, the model like ResNet or Inception has been trained on millions of images and learned to identify general features like edges, textures, and shapes. We can use the knowledge and fine-tune the model on a smaller data set, saving time, reducing the need for data, and improving performance. Now coming to the setting up the environment. All right, so before we dive into code, you should have the TensorFlow installed. If you don't know how to install, you can definitely start with pip install and pip install TensorFlow. That will help you to set up the complete environment used for to do anything with the TensorFlow. And also please make sure you're using Python 3.7 or later. If you are want to use a GPU for faster training, TensorFlow will automatically detect if your system is set up properly. Now let's starting by importing the libraries we need. So we will import the TensorFlow, some helpful libraries, and module for data loading and augmentation. Now after that, we have to load. We are importing the TensorFlow and VGG16 model, which is a popular pre-trained model, and we'll be also using image data generator to handle image loading and augmentation. So loading pre-trained models. Next, we load the pre-trained models. This is our base. So for this demo, we are going to use VGG160, but you can also use other models like ResNet or MobileNet depending upon your need. So we are using the pre-trained weights from ImageNet and include topical false. So this argument tells TensorFlow to exclude the final fully connected layer to the model, as we will be adding our own and specific classification task. Next is the freezing the pre-trained layer. So we'll freeze the layer for the pre-trained model to prevent them from being updated during the training. So this allows us to focus on training only the new layer that we add on top of base model. So by setting the trainable equals to false, we freeze the weight of VGG116 model. This ensures that only the layer we add will be trained. Now comes the point of adding the custom layer. So let's add this our custom layer on top of VGG160 model. We'll add the global average pooling layer, a fully connected layer, and a softmax output layer to classify our images. So we are adding a global pooling layer here, right? This one to reduce the conceptual dimension on the features map and then dense layer to perform the classification. And finally, we use a no softmax activation function for multi-class classification. Next is just compiling the model. So with our model structure ready, we'll compile it and we'll use Adam optimizer, which is great for transfer learning, and categorical cross entropy loss function for multi-class classification. Next is preparing the data. So we have prepared some random images, and so this will use the image data generator to load and augment our images. So this is just a code to generate the random images, and there are 50 classes for this. Now comes the training of the model. So after preparing the data, we'll train the model. So this I have already trained because it took a lot of time, and we can evaluate our model. So we trained the model for 10 epochs, but you can adjust this depending upon your dataset size and model performance. So after training, we can evaluate the model performance on the validation set to see how well it generalized to a new data. And this will give us the loss and accuracy metrics for validation data, helping us to understand how well the model is performing. So let the evaluation get run. Great. So the evaluation is completed. The accuracy does not looks too good, but this is great. We have seen the complete flow of the transfer learning, how to use the existing pre-trained models and put up of your custom layers on top of it to get the final results. So as you have now seen how to perform image classification recognition with TensorFlow and transfer learning by using a pre-trained model and fine-tuning it to your own data set. You can achieve excellent result even with the limited data and resources. Thank you for watching. I will see you in the next one.